Invited speakers, especially plenary speakers from abroad, university participants, delegates, faculty colleagues, student friends, invitees, members of the press, ladies and gentlemen, a very good morning to all of you. We are indeed privileged to have with us Madam Roop Rashi, Textile Commissioner, Ministry of Textiles, Government of India as chief guest for this inaugural function. We are thankful to you, Madam, for accepting our request at a short notice and gracing this occasion in spite of your busy schedule. Madam, you accepted readily and gave a lot of inputs and encouragement for the conference. At this juncture, I take this opportunity on behalf of PAG to thank you and the team at Office of Textile Commissioner for the continuous guidance and the valuable support in all our activities of the Center of Excellence. You are honored by your valuable presence, Madam. I extend a very hearty welcome to you. We are happy to welcome our guest of honor who will be joining us little later.
I know what you mean by I take that at this juncture. I take this opportunity on behalf of PSG to thank you and the team at
I think Dinesh, can you switch off the YouTube? Live is coming.
Support in all over activities of the center.
SAR had visited our Center of Excellence last year along with the Dinesh, am I audible to you? Can you switch off? Video is coming. Some YouTube is coming. Yeah.
Actually, backbone, sir. Someone is running.
Yeah.
Actually, I muted all the mics. Only you and me mic is only on.
Okay. We are happy to welcome again our guest of honor who will be joining us later. He had visited our Center of Excellence last year along with the Secretary Textiles, Sri Ravi Kapoor's IAS, and gave a lot of inputs to take the products into the next level. Welcome, sir. I extend a warm welcome to our beloved principal, Dr. K. Pragasan, who will be delivering the presidential address for all his continuous support. I also would like to welcome our academic advisor, Professor Dr. Ramamurthy, for joining us. I extend my warm welcome to all our guests from universities abroad and the industry, especially Professor Prasad Patluri, Director Research, Northwest Composite Center, School of Materials, University of Manchester, UK, Professor Zungai Wong and Professor Rangam Rajkova from Institute of Frontier Materials, Deakin University, Australia, Dr. PKC Bose, Vice Chairman, Managing Director, Enercon Wind Energy, Private Limited, Bangalore, Professor Dr. Jinlian Hu, City University of Hong Kong, Professor Michael Rausch, Hof University of Applied Sciences from Germany, professors from IIT Delhi, Professor V.K. Kothari, Professor Alaguru Swami, Professor Rangaswamy, Professor Deepthi Gupta, Professor Apurva Das from Department of Textile Technology, IIT Delhi, Professor Dr. Radha Krishnaya Parachuru from Georgia Institute of Technology, USA, Professor Swapan Kumar Ghosh, Institute of Jute Technology, University of Calcutta, Dr. Badri Narayanan, McKinsey and Company, USA, Sri Vice President, Activewear, Shuttledge Textiles and Industries Limited, Sri Uday KS, Vice President, Polyester Fiber Limited, SRF, Shivakumar, Senior Regional Manager, Zwick Royal, Germany, Professor Ravindra V. Adivarekar, Professor R. Dr. Ashok Atulye, ICT Mumbai. I welcome all the invited speakers who have joined us together with us this morning. It is my pleasure to welcome all the guests and speakers from around the world on behalf of the management, principal, and the departments of Textile Technology and Automobile Engineering, and also on behalf of MS Baroda University, who is our collaborator. I extend a very warm welcome to all of you. My cordial welcome to all the invited speakers, session chairpersons, deans, heads of departments, controller of examination of PhD College of Technology, participants, industry members, faculty colleagues, student friends, invitees, members of media, ladies and gentlemen, a very good morning, and I welcome all of you all for.
Thank you, Madam.
textiles are with us, and they have textiles are on us for 24/7. They civilized us, and now they have made their way into all segments of industry. Industrial textiles offer new ways, means, and opportunities for the Indian textile industry to sustain the present growth and strive into the future. It would offer not only an opportunity to augment the growth, but also new direction for advancement of the industry. The technology mission on technical textiles, TMTT, was framed by the Government of India to promote technical textiles in India as part of the Ministry of Textiles. They have allocated us the Center of Excellence on Industrial Textiles in the year 2011 with a funding of 25 crores. And we are thankful to you, Madam, and the Ministry of Textiles for the same. We are proud to announce that we have been able to develop products such as special 3-ply masks, laminated coverall fabrics for PPE kits, which is used in the pandemic now for the doctors' coveralls. We have also developed baby bed protectors, effluent filters, wet wipes. This is just to name a few, which are being marketed by one of our incubatee and also through various entrepreneurs. This INDUTECH 2020 marks the 5th edition in the series of conference organized by our Center of Excellence. The earlier ones were held in 2012, 2014, 2016, and 2018, now currently 2020. Though the wheels started for the conference in the last year itself, we were caught unawares by the COVID pandemic. Though we were going through an unpredictable period, we decided to go ahead with the conduct of the conference with the help of technology and with the help of our collaborators. We decided to go ahead with this online webinar mode. In this regard, I would like to acknowledge and appreciate the support of all our collaborators, Office of Textile Commissioner, especially Madam, Textile Commissioner Madam, Department of Textile Engineering, MS Baroda University, Hoff University, Northwest Composite Center, University of Manchester, Deakin University for making this conference a successful one. I also take this opportunity to thank all our invited plenary speakers and all the chairmen who will be chairing the plenary sessions in the plenary sessions. Last but not the least, I thank all the participants. I am sure the deliberations over the next 2 days will enlighten us on the field of industrial textiles. As the Tirukural says, "Ulayum uppakam kanbar ulayvindri thaladu unatruvavar," who strive with the undismayed, unfalling mind, at length shall leave opposing the fate behind. As the Tirukural says, the successful organization of this conference owes much to the teamwork of our Department of Textile Technology, Automobile Engineering. In particular, I would like to appreciate and congratulate the organizing secretaries, Dr. Periyaswamy, Dr. Krishnaswamy, Dr. Sendil Kumar, and other team of people from my department and various teams. I also take this opportunity to thank all my collaborators, without whom this conference would not be a successful one. I take pleasure in welcoming you all once again and wishing you a wonderful 2 days of experience. Welcome all of you.
Thank you, Madam. We now call upon Dr. S. Neela Krishnan, Professor and Head, Department of Automobile Engineering, PSG College of Technology, and the convener, INDUTECH 2020, to brief us about the conference.
Respected dignitaries, advisor, Dr. Ramurthy, deans, heads of departments, invited speakers, industry participants, delegates, faculty colleagues, student friends, invitees, members of the press, ladies and gentlemen. A very good morning to you all. I also join Dr. G. Tilakmati in welcoming you to this INDUTECH 2020. I think this would not have been possible but for the technology available today. The genesis of this conference started in the year 2012 when we were selected by the Ministry of Textiles from among 26 colleges and textile research associations in the country to set up the Center of Excellence on Industrial Textiles with a funding of approximately 25 crores. We are proud to say that today we have a fully operational state-of-the-art center operating at our Neelambur campus. The objectives of this center include R&D, consultancy, prototyping, incubation, testing, and standards development. The center is the outcome of the efforts of the departments of textile technology and automobile engineering with the objective of interdisciplinary research to develop eco-friendly products with a specific focus on acoustic, thermal insulation, and filtration products. I am proud to announce that we have developed around 14 products, incubated 10 entrepreneurs, and signed MOUs with more than 10 companies. Some of the major beneficiaries, which are well known in the Indian scenario, are Carborundum Universal, SRF, TVS, Renault Nissan, Midas Filters, Roots Industries, and Pritcor, to name a few. We have since then also set up a focus incubation center with plug and play capability for entrepreneurs to be incubated before starting out by themselves. This center for focused incubation center has been started with an outlay of 2.85 crores, again provided by the Ministry of Textiles in 2016. Coming to this conference, this is the 5th edition of the biennial INDUTECH series and comprises 7 plenary sessions with 19 presentations on several themes, which I'm going to read out. Fibers for industrial applications, recycling and sustainability, textiles filtration, agro and performance textiles, automotive textiles, medical textiles, and enzyme finishing. Similarly, we have another session for composites and coated textiles. These will be handled by invited speakers from industries and universities abroad and in India. We also have 9 technical sessions comprising of 45 selected papers on the themes of nonwovens, functional finishing, sustainable and eco-friendly processing, composites, medical textiles, protective textiles, home textiles, fibrous products, civil applications. These are all handled by academicians and researchers across the country. Similarly, a separate poster session for students and researchers has been arranged under 2 groups with the themes nonwovens, smart and home textiles, and nonwovens, smart and home textiles, composites, acoustics, sustainable and home textiles. I would like to recognize the plenary speakers, the invited speakers. These are Professor Dr. Zungai Wang from the Institute of Frontier Materials, Deakin University, Australia. Dr. PKC Bose from Enercon Wind Energy Private Limited, Bangalore. Dr. Jin Lian Hu from the City University of Hong Kong. Professor Dr. Prasad Kotluri from University of Manchester, UK. Dr. Michael Rausch, Hof University, Germany. Dr. Radhakrishnaya Parachuru from Georgia Tech, USA. Dr. Rangam Rajkova from Deakin University, Dr. R.S. Rangasamy from IIT Delhi, Dr. G. Badri Narayanan from McKinsey & Company, USA, Shri Pankaj Verma from Satluj Textiles and Industries Limited, Mumbai, Dr. Swapan Kumar Ghosh, Institute of Jute Technology, West Bengal, Shri Shivakumar from Zwick Royal Private Limited, Singapore, Dr. Ravindra V. Adivarekar, ICT, Mumbai, Dr. Ashok Atalye, Institute of Chemical Technology, Mumbai, Dr. V.K. Kothari, IIT Delhi, Dr. Deepthi Gupta, Dr. Alagarisamy, Dr. Apurva Das, all from IIT Delhi, Sri Uday from SRF Limited, Chennai. The plenary sessions are to be chaired by Dr. Alagarisamy, Dr. Rangasamy, Dr. Deepthi Gupta, all from IIT Delhi, and by Dr. Swapan Kumar Ghosh, Institute of Jute Technology, Dr. Rangam Rajkova from Deakin University, Dr. Prasad Kotluri from University of Manchester, and Dr. Ravindra V. Adivarekar, ICT, Mumbai. Similarly, the 9 parallel technical sessions are to be chaired by Dr. J.C. Saktivel, Dr. P. Ganesan, Dr. M. Sendilkumar, Dr. T. Karthik, Dr. S. Viju, Mr. G. Maheshwaran, Dr. H. Ram Mohan, Dr. K. J. Vishnuvardhini, and Dr. R. Murugan. Postgraduate and PhD scholars are presenting their technical work in the poster format, which will be also displayed. I'm proud to announce that as of last night, we've had 623 registered participants for this conference. I take pleasure in wishing you all an enlightening 3 days at the online conference. Thank you very much.
Thank you, sir. We now request our beloved Principal in Charge, Dr. K. Prakasan, PST College of Technology, Coimbatore, who has supported us in all our endeavors to deliver the presidential address.
Chief guest of the inaugural function, Ms. Rubrashi, IA and AS, Textile Commissioner, Ministry of Textiles, Chairman, Sri L. Gopalakrishnan, Managing Trustee, VSG and Sons Charities, Sri Nihar Ranjan Das, Joint Secretary, Ministry of Textiles, Dr. Tilagavati, Professor and Head, Department of Textile Technology, Dr. Neelakrishnan, HOD, Automobile Engineering, Professor B. Ramurthy, Advisor, Academic, VSG Institutions, other dignitaries, keynote speakers, delegates, supporting industries and universities, media, ladies and gentlemen, a very good morning to all of you. I join the organizers in welcoming all of you for the 3-day conference on industrial textiles, products, applications and prospects, organized by INDUTECH2020 and the departments of Textile Technology and Automobile Engineering. And I thank them for giving me an opportunity to meet many experts in the field of textiles in web. The topic of discussion, it varies from conventional to very high level discussions, but basically food, shelter and clothing are very crucial for the humanity at any point of time. When we are not doing good, we use the bare minimum resources. When we are extremely rich, we can go to the other end of fashion of everything. But at the time of crisis, everything becomes scarce. At this point of time, we know the need for equipment, whether it is plastic, whether it is fabric, made of fabric, to protect from infections. So it should have its own power to prevent the infection, not only as a barrier. I will give a small example from the epics. How it may look very old or crude. In my native place, there is a tree. Its circumference is about 50 meters, but it is not a solid cylinder. It is like an arc. Once its branch fell down, that it itself was like another tree. But that tree is a rare tree. Its hide is used for the what you call that in Sanskrit, you call it as Valtkalam. It is like a dress. It is highly malleable and you can crush it and it becomes a huge sheet of material which can be used for making dress. So that may be the origin of making protective dress for everybody, or those days how they lived we do not know. Similarly, in the other side of textile, in our Ramayanam, there is one event when Sita was in Lanka for a long period. Before they left, they have met one sage by name Atri, and his wife name is Anasuya. She gave a very special dress to Sita. It will never be tarnished or it will never become blemished by dirt or anything. How infinite protection from everything. And that cloth protected Mother Sita for a very long time. So these may be stories for just for listening or something, but dreaming of highly impossible or very difficult things to achieve. But the range of topics are very thought-provoking, relevant to the time on protection from infection, low cost, then the environmental issues, the amount of water we use, amount of detergents we use, and I think that also adds to the environmental impact. So these discussions during the deliberations that will be held for next 3 days will bring a new thought wave in using resources, in protecting environment, and helping humanity in a better way. I wish all the best and great learning for the next 3 days for all the delegates. Anyway, the part of hospitality now everything is online, so I request you to accept our sincere and heartfelt hospitality through web. And I thank all of you being present and giving me an opportunity to talk to you. Thank you.
Thank you, sir, for your valuable and informative address. Due to unavoidable circumstances, our beloved Managing Trustee, Sri L. Gopalakrishnan, PSG and Sons Charities, is not able to join us for today for the inauguration. He has graciously sent us a message which will be read now. As Managing Trustee of the PSG and Sons Charities, I take this opportunity in joining the Departments of Textile Technology and Automobile Engineering at PSG College of Technology in welcoming you to this 5th International Conference INDUTECH 2020, Industrial Textiles, Products, Applications and Prospects, to be held from August 21st to 23rd, 2020. I'm happy to see that this conference is being held in collaboration with the Office of Textile Commissioner, Ministry of Textiles, Government of India, Department of Textile Engineering, MS Baroda University, Hof University of Applied Sciences, Germany, Northwest Composite Center, University of Manchester, United Kingdom, and Institute of Frontier Materials, Deakin University, Australia. I have been keenly observing the growth of the PSG Tech COE INDUTECH, the Center of Excellence on Industrial and Home Textiles, PSG College of Technology, since 2011, when it was sanctioned by the Ministry of Textiles as part of the Government of India's Technology Mission on Technical Textiles for promoting the technical textiles industry as a whole in India. I'm impressed with the way the center has now taken shape and happy to note that it is now fully functional and serving the society for which it was sanctioned. I'm especially delighted and proud of the achievements of the center during this COVID-19 pandemic period. The center has been continuously operating and providing to hospitals, MSMEs, entrepreneurs, and the public essential products such as 3-ply surgical masks, laminated coverall fabrics used in combating the COVID-19 pandemic, and also operating manufacturing and testing services to support the technical textile industry. On behalf of the management of PSG, I take this opportunity to thank the chief guest, Ms. Ruprashi, IANAS, Textile Commissioner, Ministry of Textiles, Shri Nihar Ranjan Das, IRSEE, Joint Secretary, Ministry of Textiles, the international collaborators, plenary speakers in the conduct of this conference, and also to the participants. I strongly believe that such conferences provide a platform for knowledge sharing and networking among the academic and industry fraternity, resulting in world-class research and opportunities for industry to transform this research into useful products and services for the society at large. My appreciation goes to the conference organizers and wishing all of you the very best. Stay home, stay safe. We would like to place on record our sincere thanks to our Managing Trustee for his constant strength and encouragement. We are honored to have amongst us Ms. Ruprashi, IANAS, Textile Commissioner, Ministry of Textiles, as our chief guest. Ms. Ruprashi has taken over charge as the Textile Commissioner, Government of India on 11th June 2020. She belongs to 1994 batch of IA and AS and was Director General Audit with the Office of Comptroller and Auditor General of India prior to joining the Textile Ministry. She has traversed wide set of portfolios, gaining experience from policy and execution in development administration, as well as the policy program implementation in commodity sector, in addition to her experience of international auditing, as well as auditing Government of India and state governments. She has done external audit for United Nations Organization, Geneva, Food and Agriculture Organization, Cairo, Egypt, Syria, and led mission audits in Southeast Asia. Working across Madhya Pradesh, Odisha, Karnataka, and Maharashtra, she covered audit of commercial enterprises, which includes financial sector, central and state, revenue audit, while automating the service functions of state offices of Accountant General in Karnataka. She worked as Secretary, Finance Fiscal Reforms, Government of Karnataka, Bengaluru, since 3rd September 2012 to 14, leading initiatives for strengthening systems for proper conduct of public finance on Government of Karnataka, facilitating and monitoring externally aided projects of World Bank and ADB, coordinating efforts for financial inclusion, including electronic benefit transfer in Karnataka, establishing integrated financial management system, Kajine 2, among others. As Director Fiscal Policy Institute, she commissioned activities of this unique state-of-art institute for all the finance sector departments, preparedness for GST for departments and dealers, alongside developing research verticals relating to various infra-sector implementation formats. As Director of Finance, Coffee Board of India, Ministry of Commerce and Industry from September 2007 to September 2012, she led efforts for developing the strengths of the commodity across the value chain from farm to retail, domestic, and export. With this brief introduction, we now invite Ms. Ruprashi to address the gathering.
Madam, please unmute your mic.
Ready? Am I audible?
Yes, madam. Yes, now it's audible.
Dear Dr. K. Prakasan, dear Dr. S. Neelakrishnan, my esteemed colleague, Shri Nihar Ranjan Dasji, I think he is yet to join.
Yes.
Dr. Peryaswamy, all the expected panelists and dear friends. I am happy to address this INDUTECH 2020 conference, which is fifth in the series of the conference being held since 2012. I am happy to note that we have got a participation of 623 participants. Despite this unprecedented crisis in which we are working of COVID pandemic. That this opportunity happens within 2 months of my assuming charge of the Textile Commissioner seems to be providential to me because it also coincides with the launch of National Technical Textile Mission in March 2020 and surely gives me an opportunity to ingratiate myself into requisite learning for contributing to the goals as envisaged in my new role. As all of you are aware, Indian technical textile industry currently stands at US $17 billion with a 6% share in global production. It is the fastest growing segment with the rate of 12% growth rate of the Indian textile industry. We believe that technical textiles are set to play a very crucial role in creation of new India, given their wide application, as Dr. Prakashan also mentioned, from everything from textiles to products to use, and from the divide which we say in terms of only the utility part combining with aesthetics also. However, when we look at usage, we are looking at automobile, construction, infrastructure, healthcare, aviation, defense. Most visible demystification, unfortunately, I would say, has happened for the public at large in this pandemic when they have started using the protective gear. I'm looking at the public, the user end. When they understand the importance of technical textile, is unfortunately, maybe we can say the positive side or the opportunity which this pandemic is thrown. But because of that, people have come to realize the opportunity, possibilities these challenges are throwing at us. I would, due to competition from neighboring countries and the possibilities we have, all of us know we are looking at Honorable Prime Minister has talked about Atmanirbhar Bharat. We do believe we have capacities across the segments. We do believe we need to nurture the talent, the capacities from raw material to the end use product. And in that segment, I do believe that technical textiles, which are futuristic and used for these various applications from agriculture to defense, are way to go. They need to get more space while retaining the space for the traditional textiles. Now, I was expecting Mr. Niharanjan Das to himself highlight us on the textile mission. However, at the cost of repetition, maybe he will also in any case end up doing it. I would just like to intimate the House that Government of India has launched National Mission on Technical Textiles with an outlay of 1,400 crore with implementation period from FY 2021 to 2024, 23-24. That is for the next 5 years. The aim of the mission is to reduce import dependency and enhance development of value-added technical textiles in the domestic segment. Now, in this whole mission, the focus is strengthening our raw material base by developing research on aramid fibers, carbon fibers, glass fiber, composites, etc. At present, most of such specified material are being imported. So we are looking forward to you as the knowledge partner to help and the industry to take forward this whole exercise of looking at becoming ourselves a producer and go for import substitution. India is promoting usage of technical textiles in the field of agriculture, healthcare, transportation, civil sector, mining, defense, aerospace, ballistics, composites, with potential other government departments. Am I audible? Yeah. Now, all this also requires that most potential technical textile products need to be identified. Domestic and export demand, we need to develop. Awareness creation among common consumers, which is farmers, end-use industry, etc. Where I use the word demystifying, which I do believe that when we look at it from a very technical perspective, it may seem like not comprehensible. But as Dr. Prakasam said, that most of the things become next door things when we start using them or when we start understanding the import. You might have seen that we do have a lot of fabrics in the market now saying we are 99% COVID free. Now, what does it mean to a lay user? We expect that all that we are able to demystify to the user end. We need to incentivize projects, and with this we are looking at also developing our own standards, Indian standards for technical textiles across all segments, with more emphasis on use of indigenous manufactured material under Make in India. So it's a very ambitious project. I am looking forward to Mr. Nihar Das, who is the coordinator for the project, also to member secretary, to enlighten us all when he addresses us all. And it's just that I wanted to highlight this because when I look at this mission and I look at the mandate we gave in 2011 to the Center of Excellence, I see a lot of synergy. Now, the synergy comes from developing facilities for testing and evaluation of products of identified segments. which you said you have already developed, to be a resource center for industry across the board, facilities for indigenous development of prototypes. Now, this was one thing which when I got in touch with Ms. Madam Tilagavati only a couple of days back, and I was looking at what is the output since 2011. And I am told in this segment, you have developed a lab model punching line, coating and lamination line, filter manufacturing, complete testing facility, coir needling line, working on thermal insulation products, oil soration, and acoustic products using coir fiber. Now, this vertical needs to be continuously strengthened. This indigenous, the third vertical, the third mandate needs to be continuously strengthened if India needs to be Atmanirbhar, as well as target joining the leader. We need to be the leader, which we have already shown in some segments. We have the second largest producers in some segments of products which are being used to combat the pandemic right now. And if we can develop solutions for the human race. And obviously, we look forward for this center to cater to the training needs of the segment across all skill segment. Now, this particular event today we are having, which is a major knowledge sharing exercise organized by the Center of Excellence. I am happy to note that we have experts from National International Center. I won't like to again repeat. I actually had noted down for my own knowledge. So from Professor Dr. Zungai Wong to Professor Ravindra Adivarikar. And I would be at loss, considering our own circumstances, not be able to join all the sessions myself. But I do look forward to some of the sessions very specifically, particularly the session regarding the sustainability. Because today, as a challenge, when we have taken up the challenge, humanity is combating the most unprecedented challenge thrown at us. We are having solutions, but we are developing solutions to provide protection to all our COVID warriors. However, simultaneously, this was the first thought when I joined the ministry and I was asking one of my colleagues. The first thing which strikes is we are getting back into the products which have very, very long life, which are not biodegradable. So do we have solutions in a way to manage? We shouldn't be having a solution for today, which becomes a problem for tomorrow. So while I'm sure you already have a preset agenda, which is going to be enlightening for all of us and the industry and the user, I do believe, let us look at a crisis not as on today, but prospects for tomorrow, taking the holistic angle to the problem as we are facing today. Now, I want to congratulate the Center of Excellence. They have done 14 products, though I still need to know why only patent for one has been filed. Now, with these few words, I would like to say the whole humanity is at crossroads. Today, the fact that we are having this conference in such an unconventional way, ideally, I'm sure all of us would like to sit face to face and discuss a lot of issues which do enable us to come up with solutions. Today, thanks to technology, we are sitting across the world and talking. However, we need to see that when this whole humanity is at crossroads, we need unprecedented solutions, unprecedented activity to find this way to move on. I'm happy to see that PSG College has risen to the challenge. I like the sentence used by Mrs. Tilagavati that despite COVID, they decided to go ahead with the conference. Yes, that's the spirit. We need to look at alternate ways of delivering to our stakeholders. And I am very thankful that I could join it within such a short time. And through such intensive interaction at such challenging time, I'm looking at multifarious solutions, at least a lot of insights to probable solutions. We can have more interactions consecutively later also. And it should obviously factor what needs to be adopted and what could be the cost across the board. Now, the cost definitions don't remain just financial, as all of us are aware now. I wish the organizers very best in organizing such comprehensive interaction. I look forward to learning from each session, and I would like to look forward to some very concrete solutions for the industry as well as policymakers on the issues which are facing us. Because academia is the best placed domain where we can think unconventionally and come up with something which sometimes at the execution level we are bereft of time to ponder and get into. So looking forward to the hand-holding from academia world across in finding solutions to present challenges, way forward, and growth for this segment, which is technical textiles. I would like to sign off once again, thanking the organizers for inviting me, associating me with this seminar. I wish you all the success in the deliberations. I assure that our department, the Ministry of Textiles, is one with you in taking forward the agenda of strengthening the vertical of technical textiles in the service of humanity at large. Thank you. Thank you, everybody.
Thank you, ma'am, for your insights on the textile industry. And we hope we go from strength to strength and become Atmanirbhar.
Kitana JS has joined. I welcome.
Yes.
Sir, on behalf of the conference, I welcome our Joint Secretary, Textiles, Mr. Nigar Ranjan Das. Welcome, sir.
Yeah, good morning to everyone.
Good morning.
I got delayed because of some technical problem. The WebEx was not connecting, but now it's okay.
Welcome, sir. Welcome, sir. I am Prakashan from PSG Tech. Welcome.
Yeah, it's a webinar, or there are people physical presence also of some people somewhere.
Yeah, it's a webinar, sir, but inauguration is going on.
Yeah. Now, I would have liked to join throughout the day, but because of we have some other schedules today. So I think we have one officer here, Mr. Shukla joins with a deputy secretary.
Okay, sir.
So I will request him to join for at least for the season for some sessions. And there is one interesting session I found, something called performance fabric or something, specialty fabric. What is that? It's about performance fabric, it seems.
Which one, sir?
Performance fabric. Yes.
Session number, sir. Session. Which session, sir?
It's about something called performance fabric.
Oh, okay, sir. I'm not getting it. Okay.
I think it is session 3. There is something called performance textiles.
Yeah. Performance textiles. Yes, sir.
Yes, textiles. Yeah. So what I'll do today, we have one. We are now started working on National Technical Textile Mission.
Yes, sir.
So we had 3 rounds of discussion arranged with industry, arranged by CII and the FICI and ITA also, one with ITA. So now we are taking up National Technical Textile Mission.
Yes,
so going through. Am I audible or some?
Yeah,
yes, audible.
Audible. Okay. So we are in taking up National Technical Textile Mission. As a part of that, we had around 3 rounds of discussion with the industry through CII, FICI, and ITA. And now we are. We also had 1 round of discussion which our minister herself chaired. That was with IITs. And then now today we are having a focused discussion on geotextiles that is arranged by CII, but it will be all the major geotextile industries who will be and today's meeting will be attended by Secretary Textiles, Secretary Ministry of Road Transport and Highways, and a Secretary level officer from Railway Board. So this is on geotextiles in roads and railways. They are getting more and more focused right now, and because I somehow I didn't have much of a database about who are all working in technical textile. I know the focus. I know this center of excellences, but so PSG College, PSG Center of Excellence will like to. Today. I think you must be busy, but if somebody can join at 4 o'clock, That will be hope because it's all inclusive. Everybody can come and join. So what I'll do, I'll send the link today, web link, which is from 4 to 6, and about 10 to 12 geotech manufacturers, geotextile manufacturers, along with Ministry of Road Transport, Central Road Research Institute, National Highway Authority of India, Railways, all are participating. So that will be, you can all contribute, all are welcome. So starting, I'll just, I won't take much time. I think it's slightly delayed for you. I'll just go straight to the things we are doing. What we want, the government is very clear on that, and this mission is driven by Prime Minister himself, not by Prime Minister office, Prime Minister himself. He knows, he has a keen interest in technical textiles. He knows it well. He has been briefed well, and he wants technical textiles to be something big in India. Next 4 to 5 years, like we are today called a major manufacturer and exporter of textiles, we should also be major manufacturer and exporter of technical textiles. For that, we have a 3-4, I mean, stages, 3-4 stages, or 3-4, I can say 3-4 different forks. Number one is we have to promote the use of technical textiles in India. And in certain cases, we have mandated use of certain technical textiles across the government uses, such as agrotextiles for agricultural, national horticulture mission and national agriculture mission. Geotextiles largely being used by road sector, national highway sector, also by, to some extent, by railway sector. We have got that mandated. Medical textiles, a large numbers are now mandated, but there are certain implementation problems. So the one is to, but these are all, before I go further, one thing I have found out in last 1 year or so, that is our technical textile uses are always low tech. They are not addressing the high tech. They are not addressing the cutting edge of the technology. We are at a very low tech. Out of the 17 billion USD technical textile market that we speak about, meeting चल रहा है अभी नाना नहीं. The market we are speaking about, 40% or so is packaging textiles. It's all non-wovens, bag material, then all intercontinental packaging material kind of thing. But they are not the best in the world. Even when we started some probing something into agrotextiles, we had a scheme called use of agrotextiles, promotion of agrotextiles in northeast region of India. And we found that the agrotextiles that is being used, we compared with agrotextiles being used in Israel and Arab countries and Japan and Europe, and found that they are all much superior, much advanced, adaptable. But the ones used in India are very basic level. Just by saying that we are using agrotextile, geotextile doesn't serve the purpose. We have to address the best technology in the world. So we are deciding to focus on few areas. One of the areas is we have identified 10 HSN codes, which are the highest traded technical textile products in the world. The 10, if somebody in chat, I can share it, or I will share it on the ministry website. Out of the 10, the largest ones are airbags of the automobiles and all the diapers kind of thing. The hygiene products, sanitary napkins, baby diapers, adult diapers, and all those their components. These are supposed to be, and there are other non-wovens and other materials, of course. So once having identified the 10 largest traded, and these 10 constitute 80% of the total volume, total value in money terms. Out of 120 USD billion that is traded in the world, 80 billion belongs to these 10 categories. So that is the focus area, and we like to promote the investment, promote research, technology, everything in India in next 1 or 2 years. That will be our focus investment group sector, and it is being framed as a policy of the ministry for export promotion. So wherever there is export promotion scheme, we will try to we'll see that these 10 are always for the priority category. Then coming back to the use again, there are government is the present government is planning large scale infrastructure development for the growth of economy in the country, and roads, railways, ports constitute the major share of the. Of course, it will constitute metro rail kind of things also. And I have just done some small research and found technical textiles can really make a huge technological change in terms of the life cycle cost reduction, the longevity of the infrastructure, their maintainability, and also they'll increase their capacity, their load bearing capacity as well as their traffic bearing capacity. So today's geotech discussion which we are having today with the industry, one of the focus is to go for the cutting edge technology. We have identified 3 areas. I think there is some echo. There are 3 areas. One is to find out where we can substitute the conventional use with technical textiles, and for the betterment of the users, not for the for the growth of technical textile per se. Second is to find out where how do we compare the best in the world, and suppose any product that is being used here, does it compare the best technology in the world, latest technology in the world, the state of the art technology in the world? And if not, how to bridge the technology gap, whether through investments, whether through machine manufacturing, whether through a technical know-how. And particularly in technical textiles, these are application areas. These certainly require somebody using technical textile in the road must know how to lay it, how to make it a part of the construction. So that is another gap area, skill gap area. We are trying to not only trying to bridge the production skill gap, also trying to bridge the application skill gap. So in the National Technical Textile Mission, we have got 400 crores. That is for the development of skill, development of education, research, not research exactly, research in the educational institutes. The educational institutes need good laboratory infrastructure for to build the skill, build the kind of education, kind of engineering base and all that. So that will address the civil engineers, the agriculture engineers, the agriculture engineers, also the people who use in various uses like medical, the doctors. The doctors need to know how to use a technical textile, how to use a artificial valve or a artificial kidney. So that kind of a knowledge dissemination has to be there. So we have kept 400 crores to be spent in next 2 to 3 years in building a sound, solid educational and skill development base, going to the best, the largest in the technology. Not a base will automatically come in. Then the next part is the money is not a criteria as long as it addresses the economic growth. We will have a lot of demonstration centers, lot of knowledge dissemination, people interaction with the other countries, the advanced countries. That seminar conference will be of course a part, visits will be of course a part, but there is a lot of knowledge gap, there is a lot of lack of understanding. There is a lot of people when I approach, they don't know what technical textile is and they don't know how to use it. Even I am from railways, and I found that railway civil engineers were very reluctant to use technical textile. They say it is costly, it is not suitable, the products are not available in the country, the technology is not available in the country. That kind of a mental blockade is still there in India among the users. So we will penetrate to the users as quickly as possible. I don't know, you may have a different data. I have got some data that penetration level in agriculture is about 5 to 10%. That means the technical textile which could have gone to agriculture wherever it is possible as per the technology available is only 10% we have gone into, and 90% is they don't use technical textile where they could have used. Similarly, geotextile, it is about 30%, largely because the road national highways use it, the railway doesn't use it. Ports to some extent use geotubes. Then medical textile is about 5 to 6%. The only thing that is we call technical textile is the bandages and gauges and all that. Not in the really the high-end technical textile, medical textiles are used. Even protective textiles, is one area. There are product textiles have, one is medical product textiles, other is industrial product textiles. There is a product textiles for firemen, petroleum, chemicals and all. And only the very extremely few companies or the industries use protective textiles. The only ones that is used are by military, and the military also is looking for much better quality of products. Military is a entirely different area. We have divided the protective textiles in two categories. One is military use, the other is non-military use. With non-military use, today there are a handful of manufacturers in the country who produce that, and they are not comparable to the best in the world. Either it is not that protective or it is heavy. Like for example, last 5 to 6 months we worked very hard with medical protective textiles for the PP, what you call PP for the COVID-19. India was not a manufacturer. We developed fabrics. Many of you might have supplied fabrics or garments to the government of India. But the question comes here is that is not compatible. It is not breathable. We had no choice because we had to develop in a wartime basis. The question is, why not find a compatible, washable, durable kind of a medical textile which can serve the longer purpose, because medical emergencies won't give you much chance to come. They come immediately. Defense protective textiles won't give you much chance. If there is a war, people need defense protective textiles, and there are a lot of challenges. So the scope is very huge, scope is large. There is a market awaiting, it has to be tapped. Government is keen to promote research, education, skill development, growth, but somehow there are many dots, they are not getting connected. So all of you who are working in technical textiles are welcome to participate. Your views are welcome. With you, PhD, I will have another, after this is over, maybe about 1 hour, I'll give a date sometime next week, about 1 hour, half an hour, 1 hour. We'll sit with some officers. I will invite ITA and PK and all who are working closely with us. And we can take up some issues, particularly I have some knowledge of geotextiles, agrotextiles, medical textiles, but have absolutely no knowledge about industrial textiles. So I'd like to interact with you, how you can proceed. You can, in the meantime, work out. You can go through the National Technical Textile Mission, the components. If you do not have, I think they are already on the website, Ministry of Textiles website. So please go through that and let us know how you can contribute, in which area you can contribute. You are always welcome to participate. You are always welcome as a partner. But the thing is, we have to go very quickly. The time is very slow. I mean, the present government wants everything to be done. Some results have to be achieved by 2024. So we are in a hurry, of course. So I wish all the best in your webinar today. But the results, I would like to go through all the presentations. Personally, I'll go through. I will have an interaction session sometime about 1 hour next week. And thereafter, you are welcome to participate in all our endeavors. We'll make you a partner. So with this, I think I should close now. Time is about 10:40. So the webinar must start. Thank you.
Thank you.
Thank you, sir. It was really an honor to listen to you. And on behalf of PSG Tech and CEO INDUTECH, we assure your good selves that we'll strive our best in the area of technical textiles. We now call upon Dr. S. Periyasamy, Associate Professor, Department of Textile Engineering, Faculty of Technology and Engineering, the MS University of Baroda, Vadodara, and the Organizing Secretary, INDUTECH 2020, to propose the vote of thanks.
Periyasamy, are you there? Periyasamy, Dr. Periyasamy?
Periyasamy is there.
Dr. Periyasamy, are you there?
Yes,
He's there, sir.
he's there. He's there.
But he is not speaking.
Kindly unmute yourself.
Not connected.
Periyasamy sir.
Yeah, he's connected.
Periyasamy, sir, unmute your mic and talk. Where is he, sir? I'm not able to see.
Periyasamy sir have some connectivity problem, ma'am.
He has some connectivity
There is
issue.
some symbol, you know.
He muted his audio, his
Due to
speaker.
low
That's
bandwidth
Buddha.
or local
மேம் அவரோட
video is not
பெரியசாமி சாரோட மைக்
available.
ஆன் பண்ணியாச்சு, அவர் பிரசன்டேஷனாகவும் கொடுத்தாச்சு. பட் அவரோட நெட்வொர்க் ப்ராப்ளமா இருக்கு. எக்ஸ்பிளனேஷன் சிம்பிள் வந்துட்டு இருக்கு பாருங்க, அவரோட இதுல எல்லோ கலர் மார்க் சிம்பிள் வந்துட்டு இருக்கு மேடம்.
Okay, okay.
பெரியசாமி சாருக்கு.
Okay, Mariam, then you can
Due to some
thank and then conclude.
Kirtana. Continue.
Kirtana, can you thank and then we'll conclude now.
A heartfelt thanks to one and all for being with us for the inauguration of INDUTECH 2020. Kindly join us back for the first plenary session, which begins at 11 a.m. Thank you once again and wishing you all a wonderful learning.
Sir, madam, before we conclude, I request all the panelists, chief guests to join us for a group photo, madam. Madam, sir is there. N.S. Das, sir is there. We will take one group photo from the screen itself. Yeah, I could see principal. Yeah, Prasad sir, welcome. Yeah, all of you can join, most of us. I saw Professor Zungai. Professor Zungai can join. Yes, advisor sir.
And Jinglian who ma'am also there.
Where is Jillian? Jillian, happy to welcome. Where are you? I'm not seeing. Professor Zungai, welcome. Professor Zungai sir, unmute your mic and talk. Welcome. Hi. Good morning, Professor Zinglian. Good morning.
Morning. I think Jin Yan is unmute.
Thank you. Professor Dr. Deepthi Alagarasamy sir, welcome sir. Hi. I'm seeing Pankaj Verma. Maybe we will take Dinesh, can you take a picture of all the panelists and the invited speakers? Dinesh, am I audible to you, Dinesh?
I am taking them.
Yes, yes. Jinlian, welcome. Professor Rausch is here. Ghosh, Professor Ghosh sir, welcome. Prasad sir was there.
Hello.
Yeah. Dinesh, எடுத்துட்டீங்களா? Have you taken?
எடுத்துட்டேன் மேம், ஆல்ரெடி டேக்கன் மேம்.
Okay, I thank all of you. Thank you, madam, especially, and for yes. I thank all the plenary speakers for joining us, Professor Deepthi, all plenary speakers. I thank all of you for joining us. We will have 2 days of learning. Thank you very much, all of you. We will join shortly after.
Thank you, everyone.
Thank you.
Wonder whether I can try to see if I can share my PPT first.
Yeah, sure.
Break.
Dinesh, can you help Professor Zungai to share? He is the first speaker.
Yeah, ma'am. I just changed to him presenter, right?
Yeah. Professor, he's the first speaker, invited speaker from Deakin University, Professor Zungai Wong. Professor Zungai, you can join, you can try.
I changed it to him, ma'am. He's a speaker and he's
Yeah,
a presenter also, ma'am.
Is it okay?
Yeah, ma'am. Please start.
Share content, share screen. Can
Yeah,
you see
we are
my?
able to see that.
You can see my screen.
Yeah, it's visible. It's
Yeah?
visible.
It's
Yeah,
visible. It's visible.
Sir.
Oh, it's visible.
Yeah.
Okay, so
Thanks. How are you, sir?
good. Now let me stop sharing. I just want to make sure it works. So, okay. Oh, that's
Yeah,
good. Yeah, because we normally use Zoom for conference meetings here.
Okay.
So this is, I think, the first time I'm using WebEx.
Yeah.
I'm glad. I think the instructions sent to us are very good, very clear. So,
Goes to Perisami.
lots of good instructions, so that helps a lot. Mm.
Professor Jungaiwang, good
Yeah.
morning. This is Professor
Morning.
Ayasami from IIT.
Yes.
I'll be the chairman for the session. You can also check whether the slides are changing.
Oh, yeah. Sure.
Yeah.
Yeah. Okay. So you can see the.
I can see the
slide.
slide. Yeah. Can you try to change?
Oh, good point. Oh, yeah. Is it changing?
Yes, it is changing. Yes.
Okay. Oh, that's good. Oh. Yeah, I actually have another meeting on, but I'm muting the other meeting. So so I've got another meeting on this computer. Yeah.
அதல்ல அதையுமே துவைக்க போட்டேன்னா ரொம்ப திக்கா இருக்குது இப்போ
So we've got 8 minutes, right? Before. So I might just go get some water first. We'll come back.
Sir. Professor Jillian, how are you? Just after a long time, I'm seeing. We met in China. After that, now only I'm seeing you. Professor Jillian, am I audible to you? You can unmute your mic and talk, those who want to talk. Professor Jillian?
Dinesh?
Yes, sir.
Can we start now?
Yes, sir.
Ganesan sir.
Sir?
Actually, Ganesan sir,
Yes, sir.
Alagiri
Yes,
Sami
sir.
sir வந்துட்டு intro கொடுக்கணும்னு சொன்னாங்க மேடம் இப்ப சோ மேடம் கிட்ட பேசிட்டு இருந்தேன்.
Madam.
Sir, Alagiri Sami sir.
Madam, good morning. Shall we start the session?
Yes, Jay. Yes, you can start the session.
Ma'am, இன்னும் Alagiri Sami sir வரல ma'am.
இல்ல சார் இருக்காரு. I will introduce sir and we will start.
Ma'am, sir, can you switch on your video, sir? Alagiri Sami sir.
இருப்பார் ஒரு நிமிஷம் இருங்க. டிஸ்கனெக்ட் ஆயிடுச்சா சார்? போட்டோ காணுமே. ஓ, அஜய் பண்டிட் சார், வெல்கம்.
I'm coming. 1 second.
Okay, sir. We are search. Yes, you can start. Sir is coming.
Okay, madam. Okay.
Check பண்ணிக்கங்க. Sir, can you unmute your video, sir? Sir vantar, you can start.
Sir, good morning,
sir. Yes, sir.
Yeah.
Sir, I will introduce and we will start, sir.
Okay, sir. Okay.
Very, very good morning. Very happy to welcome you all for this 5th International Conference on Industrial Textiles, Product Application and Prospects INDUTECH 2020, and Plenary Session 1, Fibers for Industrial Application. I am very happy to introduce our well-known professor, Dr. Alagiri Sami sir. Professor completed BTech Textile Technology in PhD College of Technology in 1983, then MTech Textile Technology in Indian Institute of Technology in 1987, and PhD from Georgia Institute of Technology, Atlanta, USA in 1994. Now, Professor personal experience includes worked in Voltas Limited India 1985, sales engineer 1987 to 88, and worked in Customs Composite Limited, Atlanta, USA, process engineer 1994 to 1996 to take care of R&D in product development. And then Professor worked in PhD College of Technology in Coimbatore 1996 to 1998. Then joined in Indian Institute of Technology, Delhi in the 1998. And Professor's research interest includes yarn structure and property, hybrid yarns and textile sector for composite material, and technical textiles, productive clothing, and clothing comfort. And this Professor publication, total number of publication journals, around 86 international journals paper, and total number of publication international Professor books and authored books, written 8 and organized international conferences. And 6 file pattern. And thank you to have a valuable person, sir. And now I request our Professor Dr. Alagiri Sami sir to take over the plenary session. Please, sir. Sir, unmute, sir. Please.
Sir, unmute your mic and talk, sir. Professor, sir. Sir, it should come in black.
Yes, sir. Yes, sir.
Yeah. You can hear me now?
Yes.
Sir. Please, sir.
Okay. Thank you, Dr. Shaktivel, for the nice introduction. And good morning and welcome all of you for this 5th International Conference on Industrial Textiles, Products, Applications, and Prospects, being organized by the Department of Textile Technology, PhD College of Technology. It really gives me pleasure to chair this first session of the plenary talks. In this session, we have 3 very interesting titles being delivered by experts in the field. Now, as a first paper, we have a paper being presented by Professor Jungai Wang on odor and smell-related properties of fibers and textiles. The second paper will be delivered by Dr. PKC Bose on advanced composite for wind turbines. And the third one will be delivered by Professor Jindyong Wang on healthcare nanowoven masks, material structures and properties. I'm sure all these 3 papers will be very, very interesting and the speakers are very well known. Now, first, let me invite Professor Jingyang Wang. All of us in the textile field know him very well. He has been there for a very long time. and he has done a lot of very important works and publications also. He is an Alfred Deakin Professor and Pro Vice Chancellor, Future Fibers at Deakin's University. Professor Wang holds a PhD in Fiber Science and Technology and a graduate in higher education from the University of South Wales. In 2005, he was awarded US Fiber Society Distinguished Achievement Award. He served as president of the Fiber Society in the year 2015. He is the editor-in-chief of the Journal of Textile Institute, which is the oldest textile journal that all of us know. Now, with this background, I welcome Professor Jungwei Wang and take over and deliver his lecture. Professor Jungwei Wang. Yeah, Professor Jungwei Wang.
Yes, thank you. Thank you very much for the kind introduction. It's a great honor for me to be invited to give this presentation. I'm delighted with the very professional organization of this event, with so many people participating in this conference. So and also good to see so many old friends at this forum as well. My very last travel, international travel, was actually to India in February this year. So I've had no more travel since then, and we may not have one for a while. So I had very, very good memory of my trip in India in February this year. So, the title of my presentation is Odor and Smell-Related Properties of Fibers and Textiles. It is an important property, and it is perhaps also a property that has not been well studied in the literature. So this is a relatively recent work done at Deakin University by research fellows and PhD students. And so I'm really delighted to be able to share. Let me see if I can. I hope to be able to move to the. So. How do I move to the next one? I think it was working a little while ago. Right. Oh, that's interesting. Let me just get out and try again. I don't know why it's not moving to the next page. Let me just try again. Right. Okay, can you see the new slide now? I hope you can.
Yes, it's coming,
okay,
sir.
all right. Okay, sorry about that. So this is a quick outline of my talk. I will show you the importance of this work and also the test protocols, the odor or smell absorption properties for different fibers, and the practical applications for product development. I think it's quite relevant to this event. And then hopefully I'll leave some time for questions. Well, I want to start by acknowledging the main work for this presentation and the sponsor for the work. The work was sponsored by both Deakin University and the Australian Wool Innovation. We actually published this work, or part of this work, last year. So my talk will be on both the published work and the relatively recent work in this space. We have, in terms of the significance of the work, I think this odor and smell, I think it's is something that we can all relate to in workplace or at home or on airplanes. And even, on airplanes, I think I actually saw this news item a couple of years ago. A passenger is suing the airline that kicked her off the plane because of complaints of body odor by people sitting next to her. So that was a bit, I don't know how the case went. I haven't been following this, but there was apparently a court case about this particular event. And the other smells, like cigarette smell and also perfume, from ladies. Either one of those can get people into trouble at home if you are not careful enough. So when actually one of the initial reasons why I got interested in this topic is a mill manager asked me to look into the smell and odor properties of fabrics, because some of his customers got complained by the partners when they come back home and there are still residual smells on the garments they wear. If it's a cigarette smell, it's annoying. If it's a smell of perfume, and the wives or girlfriends get very, very upset. So they want a way of managing the smell or managing the odor, and how and the behavior of different materials in relation to the odor or smell properties. So this is this is a couple of short videos I downloaded from YouTube. I think this one, I'll just play it. You won't see the sound, but you should be able to follow. I think this is from the former East Germany. The former East Germany, the interrogating the suspect, if you like, and then in this process they are collecting the body odor, from the seat cover. You can see the seat cover is removed, and the idea is that when you sit on the seat cover, and your odor, your smell will be transferred onto a piece of fabric attached to the seat cover. So so you can see that the fabric sample is collected. Then you can see, I will show you another video. And this one, you can see they're trying to match the samples, the smell from the sample collected with the sample they already have. And the way to match it is by actually using a dog for doing the matching. So you can see that they are actually, they've got a collection of samples already, and then they are going to put the samples, take out the samples, and then they're going to get a dog to do the matching for them to see which one matches the smell from the sample collected from the suspect. They use a foil to cover it so the smell doesn't escape too much. Here's the dog. Because dog has got an amazing nose. to detect very, very minute difference in smell. So these are the samples that were already collected. Then they're going to give the dog the smell they want to match. So yeah, that's so smell this sample first, then trying to identify the other sample with the same sort of smell. So that's I guess that's a different application of the the smell collected from individuals, right? But nowadays, of course, for laboratory tests, you can't use dogs. Right? I mean, in airports, you can still see those sniffer dogs used, right? But in a laboratory environment, you have to use a different protocol. This is actually a typical laboratory setup for smell or odor testing. Currently, usually it's in a room with well, there's quite a bit of noise here. If maybe people can mute the mic if they are listening. So they here you can see that there are 6 people. Usually you need 6 people at least to do the testing, and each individual has to be isolated from the other. So you can see the partition, and they cannot talk to each other, and they have to do the assessment individually. And the assessment is still by nose. You can see the lady's nose on the right-hand side, and still using the nose to detect the smell, right? This is the current practice, yeah, if you do body odor evaluation on a commercial scale. And then there are a number of conditions for the people undertaking the test. As you can see here, that the panelists, 6 of them, they must be free from cold or physical conditions that may affect the sense of smell. They should not use chewing gums before the test, refrain from eating spicy food, should not have shower with perfume. And so all these conditions for the panelists before they go into the laboratory to do the actual test. So it is actually a very stringent requirement for the people undertaking the test, simply because you want to eliminate any potential interference to your sense of smell when you undertake this particular task. And even the clothes they wear should be free from any other, odor. The panel work should be confidential and should not, each person should do it individually without bias the other panelists with comments. So all those is has to be strictly adhered to when you do the evaluation. And this is another similar sort of method, but the sample collection is called a triangular odor bag method. 3 bags of plastic bags, and some of them with just odorless air, and others one with the smell or odor sample. So again, using people to do the evaluation. Of course, this is a expensive exercise, and it can be a bit subjective as well. So what we have done to start with is to, first of all, develop an instrument to do the evaluation. So this is a schematic of the instrument we have developed. So we have a gas or smell injector, a gas pump, a sample chamber, and a spectrometer, and a computer to acquire the signal continuously. So basically, in the sample chamber, we put different fiber types, and then we detect the residual gas in the chamber. So here you can, here you can see a photo of the setup in the laboratory, right? So the that's the setup we use. First of all, we have to do the calibration of the instrument. You can see the absorbency and the ppm, very between the absorbency and the other concentration. In this case, we've used ammonia as the gas or odor. So we are very pleased with the calibration results, and then we tried to test the absorption properties of different fibers. So this one, you can see this is with ammonia. You can see ammonia, and of course, this is the residual smell or residual ammonia left in the chamber, right? So normalized, of course, before you have 100%. And then when you put different types of fibers like polyester, cotton, and wool, and then the residual ammonia inside the chamber, you can see the decreasing trend. The lower the curve, the more absorption by the fiber of the ammonia, right? Because this is the residual left inside the chamber after the absorption by the fibers. So as you can see that if you don't, the blank is no fibers were left in the chamber, so there is a small decay because of the diffusion of the ammonia. And then if you put polyester inside, you can see a significant drop, cotton, and then wool. Wool drops the most, which does indicate that wool probably absorbs the ammonia the most, all right? Over time, you can see the change. This is the desorption. So once the samples, different fiber samples absorb the smell, and then how does it give it out afterwards? As you can see, that polyester, the red line is the polyester. So with polyester, it just releases the ammonia quickly, very quickly initially, and then levels off, right? With cotton, similar. With wool, there is not much release, as you can see, right? The green line, which is wool. So what this tells you is that out of those three fiber types we examined, wool absorbs the most amount of odor or smell, and then it releases the least. So it just grabs the smell and doesn't actually release it straight away. All right. So that is the initial result we've got. We actually tried different types of odor because, well, I mean, in the normal odor, there are different sort of components, right? Different types of components, and there are also different types of smell. So we tried those different types. The initial result was for ammonia, and this one you can see the garlic smell, vinegar smell, ammonia we already discussed, and also smoke type of. And you can see that even for the same fiber type, in this case it's just wool, even for the same fiber type, but different types of odor, the properties are quite different. So that is a interesting result, which we were not expecting. And one thing we want to be sure, particularly in case of some fibers like you use for garments, if they absorb the odor, and what happens after washing. So in this case, it's good to see that after the number of washing cycles, the absorption efficiency actually, maintained at a pretty steady level, right? So there is a small drop, not the initial say 100%, and it maintains still above 80% after even 10 washing cycles. So that is a good result in terms of the reusability of the the material. So or if you clothes, after wearing your clothes and you wash it and it will still perform. So that is a good outcome. So this is initially we were just doing this work in our laboratory, so when we got the results, initial results, because wool does show very good property in this regard. So we actually showed the results to the Australian Wool Innovation, and then they got interested in us doing further work in this area, particularly in relation to wool polyester blends. So there's a lot of sportswear, for instance, they use polyester. And polyester, according to the results I showed earlier, is not very good in terms of absorbing odor. So, with sports garments, as you know, when you active exercise, and you sweat, and then odor can be a particular problem. So AWI is interested in us finding out if some wool is used in the product, in the wool polyester blend, whether that would improve the properties. So, and these are the samples we prepared. So 100% polyester to 100% wool. So the 100% wool we pretty much did already. And then there are 90% polyester, 10% wool, up to 50-50 polyester wool. Everything else is well controlled, right? I mean, the main variable is the blend ratio here, with the different blend ratios. We want to see how this sort of fabrics perform. So we again we selected some key body odor components, to do the evaluation. And here you can see that these results are similar. The black line is 100% polyester, and the blue one here is 100% wool. And then in between, you have increasing percentage of wool in the blend. So that trend is quite consistent with the results we got for the fibers initially, wool, cotton, polyester, right? In this case, is a blend. In the middle is the blend, but as you increase the percentage of wool from 10% to 50%, you can see the increase in the absorption of the odor under fibers. Just remember that we're talking about the residual concentration inside the sample chamber. So the lower the residual concentration inside the chamber, the higher the absorption by the fiber or fabric in this case. All right. And this is the, on the right-hand side is just the salt concentration as a percentage of wool, and just a different way of showing the result. And the emission, as you can see, that similar trend, and this is with ammonia, right? So the similar trend, polyester emits more than wool, and the different blend ratios in the middle, right? So again, similar trend. So we also, so this is, yeah, so the emission, you can see that just with 20% wool, it made a big difference. 20%. After 20%, the changes are not very significant. We also tried other component, acetic acid in this case, similar trend, right? So you can see similar trend, and also 20% makes a big difference. Again, similar, so I'm not going to, yeah, this is another type of older component. Again, the results are quite similar, right, to the ammonia. Similar story. So with butyric acid is actually is somewhat different. The trend is a little bit different, and the difference is not huge compared with some other older components. And this one is even more interesting. With acetone, you can see that the polyester wool and different percentage doesn't make much difference at all. So it's still, depending on the type of older component, the properties are a bit different. So from that result, we actually found that, if you add 20% wool, you have to make a very big difference. And we want to, but that was with our instrument, right? We want to confirm these results with the sensory test in the laboratory. So we sent the samples to, to the laboratory in Sydney to do the test, and the results came back similar in terms of the trend. You see, it was 20% wool in the blend. There was a big difference. So after 20%, if you increase to 40, 50, doesn't really make a huge difference, right? Very little difference. The other thing we did is that, so once we've settled on the 20%, so we made fabrics. So we did the wear trial. So with the wear trial, you're going to do very hard exercise. But in the t-shirt, in the armpit, left, right armpit, there was a piece of fabric sample. One of them is 20% wool, 80% polyester. Another side is, I think, is 100% polyester. So every person, when doing the exercise, the two fabric samples sewed, in the armpit area here, right, for each person. And then you do the exercise. So after the exercise, we collected the samples from the participants. You can see the black one is polyester, the red one is fabric with 20% wool, 80% polyester. Again, as you can see that the difference is big, with the, so the 20% wool blends effectively reduce body odor intensity compared to 100% polyester. So that is, I think, a quite interesting result in terms of product development. If you want to develop a sports garments, for instance, when you're going to do very, very hard exercise or sports, and you want to reduce the body odor effects, yourself and people around you, it's far better to use, a fabric which has, say, around 20% wool rather than 100% polyester for this particular application. So the results are just so consistent, and the laboratory results and the instrument results and also the wear trial results, they all are very, very consistent. So we are quite confident with this result. And we also think it's quite useful for, guiding the product development work. So I think this is what I want to share with you. And in summary, we have developed an objective tool for smell, odor, or gas measurement in our laboratory. We have evaluated the smell absorption properties of different types of fibers, and the work is still continuing. We are still evaluating more fiber types and also fibers in different forms, fabric form, yarn form, fiber form, and even powder form. And this work has informed the fiber blend selection for fabric development. In this case, I only talked about the wool polyester blend fabric, but you can do a similar evaluation for other blends as well. So that's the practical application of the work. And I just want to acknowledge the team. We have Jim Feng and Shilu, who is a research fellow and a PhD student who actually have done a lot of work in this area. If you want further information, you can have a look at this paper. I think we are publishing more papers. I think we've got a paper in the Journal of the Textile Institute coming up. And yeah, so thank the funding bodies again, the university and Australian Wool Innovation. If you would like to get in touch with me, feel free to send me an email. So with that, I want to thank you again for your attention and thank you for the opportunity to share this work with you. Thank you.
Thank you, Professor Wang. Hello, can you hear me?
Yeah.
Yeah, it's a very interesting lecture. Particularly, the topic is very relevant nowadays in a multicultural environment where a lot of international traveling are happening. So we have to be very sensitive for the order. So in that respect,
yes,
this research is a very important one, I will consider. And your video that you showed in the beginning to demonstrate the application, that was quite interesting also. I have a couple of questions before I open the floor for others.
Sure.
One is that you have demonstrated different types of fibers. They observe the odor to different levels. Any idea why this difference between different fibers? And second is you also studied on the fiber blends, particularly for polyester and wool. Will it be worthwhile? Hello?
Yeah. Hello? Hello?
Sir, hello. Alagrisam, sir, your connection got. Dinesh, can you check? Dinesh?
சார் லைன்ல இல்ல நினைக்கிறேன். அழகிரிசாமி சார் லைன்ல இல்ல. வந்துட்டார் சார் வந்துட்டார்.
Okay. Yes, sir. Yes, sir. Unmute your mic, sir. Sir, Alagrisami, sir, unmute your mic. Dinesh, unmute பண்ணல அவரு.
இல்ல மேம் அன்மியூட் பண்ணிட்டாரு.
கேக்கல? Sir, Professor Alagrisamy, sir, your voice is not audible. Dinesh, என்ன problem? Dinesh?
Alagurusamy sir, can you check your headphones, sir?
Okay,
Sir, we are not able to hear your voice, sir. Nothing went wrong, sir.
Audible, sir.
No, sir, no, sir, no, sir.
Can't.
No.
Maybe.
நம்மளுக்கு ப்ராப்ளம் பாருங்க தினேஷ்.
ஒரே நிமிஷம் சார் வந்து நான் டிஸ்கனெக்ட் பண்ணிட்டு திருப்பி மேம்.
Do you hear me?
Yeah, yes, sir.
So we can't hear the host.
Yeah. Zungai, if you have listened to the questions, you can.
Yeah, I only got the first.
சார் பேண்டமிக் பீரியட்ல இங்க இருந்துட்டு
ஹலோ கணேசன்
அவர் கனெக்ஷனை நான் டிஸ்கனெக்ட் பண்ண முடியல மேடம். அவர் பார்ட்டிசிபென்ட் லிஸ்டே இல்லாத மாதிரி இருக்கு. அதுக்காக அவர் ஆஃப் பண்ணிட்டு போன்ல கொடுத்துட்டு சொல்லணும் மேடம். வரையில நான் அவர் லைனிங் இல்ல, அவர் பேரே வரல.
வருது இல்ல, எங்களுக்குலாம் காட்டுது.
தினேஷ் சார், அழகுருசாமி சார் எக்ஸ்பில் பண்ணிட்டு மறுபடியும் ரீஜாயின் பண்ண சொல்லலாங்க சார். அப்ப வந்துட்டு நம்மளுக்கு கனெக்ஷன் கிடைக்கும்.
அதான் அவர் அதுக்காக நான்
அதான் அவர் நாட் ஏபிள் டு ஹியர்ங்கறாரே. ஒரு நிமிஷம்
நம்ம எக்ஸ்பில் பண்ணிரலாங்க சார் அவரை.
நீங்க எக்ஸ்பில் பண்ணாத, ஒரு நிமிஷம் இரு கணேசன்.
சரிங்க மேம்.
he is messaging me that he is not able to hear.
அவர் மட்டும் ஒரு மீட்டிங் வந்து லீவ் பண்ணிட்டு திருப்பி ரீஜாயின் பண்ண சொல்லுங்க மேடம் போதும்.
Okay.
Yeah, Zungai, you can answer in the meantime the questions. Yeah,
I only got the first question, which is why the different 5 types behave differently. I think if I get it correctly, that's the answer to the question. It's actually a very good question. I think it's to do with the service functional groups.
Hello.
For the different 5 types.
Sir, connection problem.
So that is why
அவங்க பேசுறது எல்லாமே கேக்குது.
Types, because the chemical makeup is different and the surface functional groups are different. So some of those groups have more affinity for the odor than others. So that's why with different fiber types the results are different. Okay.
Can you hear me? Can I ask a question?
Yeah, sure.
Yeah, how did you initiate this project? Do you think wool is naturally good odor absorber? Because you're supported by the wool research organization, isn't it? So,
as I mentioned, initially we were just doing this work in our laboratory without any support from outside organization, because we want to evaluate the smell or odor related properties of different types of fibers. So we're just playing with different types of fibers. But when we got the results in the laboratory, then in one of the discussions we had was we had a visitor from Australian Innovation at Deakin. So we just explained to them the results we've got, and then they got quite interested, and then they sponsored us to do the fabric work. So we did the fiber work initially, Then they sponsored us to do the fabric work. They actually helped with the sample preparation as well, with different blends and all that. And also they are happy for us to publish the results. So that's how I think it's a good outcome. You know, we started from our own laboratory basic research, and then that work got taken up by a sponsor, and then onto development work.
It's very interesting that it turns out wool is a very good odor absorber, is it right?
Yeah.
So that's you got a supporter from wool research organization. That means they knew these results before they give you money.
They knew this result in terms of in the fiber form, but they want to know for wool blends how much wool should be used. But
I see.
In fact, when we told them that from our results, we only need 20% wool in the blend, they were actually not too happy with that. They said, you know, we should have 50%, 80%. But we said no. We said no. The results indicate that 20% is enough.
maybe for some other chemicals.
Yeah, I was also going to ask that. Any of any fiber? Hello?
Question repeat பண்ணுங்க சார் கட் ஆயிருச்சு இடையில.
Oh, okay. Yeah, I was also going to ask the similar question that apart from blending, can you reduce the odor problem by any chemical finishing?
Potentially, yes. We haven't tried that, but the global trend has been to not use chemical finishing, right, on textiles. So if we can avoid that, it will be better than having chemical finishing on textiles.
Okay, that makes sense. That makes sense. Now, any other questions? There is a question from Rajendra Kumar posted. Does odor absorption of fiber influence sorption of virus like COVID-19?
I don't know. We haven't tested the COVID-19, so I can't answer that question.
Okay, that's very difficult also. Now, is there any other questions from the audience? You can post it. Any other questions? I think if there are no questions, we can close because we are already running a little bit short of time.
Yeah.
Sir.
Yeah.
Sir, Dr.
Okay.
Present the paper. Sir.
Yeah. In that case, we can go to Professor Jin Liang Hu. If there are no other questions, Professor Jungai Wang, thank you for the very nice lecture, very informative and useful for the present day situation. Thank you very much.
Thank you, everyone.
Okay. Now
thank you, Professor Jungai.
Thank you.
Okay. Now the next lecture, then we move on to Professor Jin Liang Hu. The topic is healthcare nanowoven masks, material structures and properties. Again, Professor Jin Liang Hu, she's very well known to all the professionals in the textile field all over the world. For the sake of the students, I give you a brief introduction about Professor. Now, she got educated in the textile engineering and materials and received PhD from Manchester University. Professor Jingliang Hu is a faculty in the Department of Biomedical Engineering of City University of Hong Kong and leads a laboratory of wearable materials for healthcare. She is a renowned scientist with industrial impact due to her unparalleled original academic research in smart materials for biomedical and textile applications. Professor Hu is a fellow of Royal Society of Chemistry, Hong Kong Institute of Textile and Apparel, and Textile Institute headquartered in UK. She is the founding chairman of Hong Kong Wellness Society and Technology Park and executive vice chairman of the Hong Kong Invention and Innovation Federation. Now, with this brief introduction, I invite Professor Jingliang Hu to take over. Professor Jingliang Hu.
Introduction. Thank for the conference chairman, Professor Tilagaf, for your invitation. Yeah, it has been a long time. We haven't seen each other. It's a great pleasure for me to come back for this conference. Today I'm coming back from a different organization. It is City University of Hong Kong. So I have a brief introduction to this university. You may never heard about it before. This is a university without textiles traditionally, but they are. This is a very progressing university. They have been doing extremely well in the past, particularly 10 years. So they are now ranked top 50 in the World University Ranking QS. It is the number one most international university worldwide. It is number 4 in the top 50 university under 50 years old. There are 22 professors in citations, and they are the 16th Asian university in also the QS ranking. I'm now in the biomedical engineering department. Biomedical engineering department is ranking number 1 in Hong Kong, number 23 in the world, and this department is within the engineering school. It is also ranking number 1 in Hong Kong, Taiwan, Macau, the Greater China area. Probably you have known me about this kind of research in the past. That's the before this year. I came to City University half year ago in March. Yeah, I used to present this one. The core research on my group is the shape memory polymers, textiles, fibers, and the composites. And with the foundation of textile materials, structural mechanics, modeling, and simulation. From this kind of research, I made a lot of friends and have been working with different industry companies. And later on, I extend this one, our research to biomaterials, bio-based materials, and wearable materials. Now, this area has been grown into whose group. It is now I have established a laboratory of wearable materials for healthcare. And still, shape memory materials, biomaterials, wearable electronics is my core. And along with it, I have Chinese medicine, energy therapies or alternative therapies, and materials for personal protection, including respiratory masks, antibacterial materials, etc. So these are my new the directions. This is the laboratory I'm leading in wearable materials for healthcare. Also make a little a small advertisement that we have positions for applications in my laboratory. Any Hong Kong PhD fellowship. This is a very prestigious scholarship across the whole Hong Kong. This is sponsored by Hong Kong government. Every year there are about 300 student candidates awarded this scholarship. It's probably this most prestigious scholarship in Hong Kong. And in CTU alone, they also have PhD scholarship, partially supported by professor by our own research projects. This is also a very good offer, and there are many positions available. Another thing is the postdoctoral fellow. You may see I don't have the research assistant positions here because it's more it's more it's more easy or it's more valuable to appoint a PhD student than a research assistant in CTU's policy. So yeah, as my research directions a little bit diversified, so the candidates for the above positions can be specialized in these different areas, from microbiology, molecular biology, electrical electronic engineering, wearable electronics, quantum physics, Chinese medicine, general medicine, mathematics, etc. And of course, polymers, fiber, science, engineering, textiles. These are still one of my important areas. I feel very interested. And I feel very interesting to know that. When I was in PolyU, I was in a textile and apparel department. I was asked to carry out projects in maybe medical areas. But when I come to CDU, people ask me to do textiles. So no matter where I go, textile is still my brand, still my symbol. So I cannot get rid of it. So I'm happy to join this conference, and I'm still a part of the textile society. Okay, infectious diseases. We are happy today to be in this online conference. The online conference is very convenient. Now I'm very used to it because I've been delivering a number of webinars since this beginning of this COVID-19 pandemic, because we cannot go anywhere. And so infectious diseases pandemic, COVID-19, has given us the opportunity to use these electronic tools, has prohibited us from traveling around, so we cannot see each other in person in the conference size. So infectious diseases has very big power. Maybe in website you can get this TED Talk by Bill Gates. He predicted actually a number of years ago, epidemics could kill more than 10 million people in upcoming decades. The failure to prepare could allow the next epidemic to be dramatic and more devastating. But anyway, this pandemic has caused fundamental change in many aspects of our world now. So we need to build, we could build a really good response system. I think one of them probably the the facial respiratory masks. So Bill Gates is right, and from the history, from the history, a pandemic diseases can be more serious, can be more powerful in damaging our human society, our the human being society as a whole. They are invisible. They are the wars with the invisible enemies. Here are some of the historical records. In the Black Death, they killed 75 to 100 million people. That is, 700 years ago, 600 years ago. And then this Spanish flu is probably 100 years ago, also caused a lot of deaths. In this COVID-19, there are 20 million people got infected, and there are a number of hundreds, meaning thousands of people got killed. The conclusion is that the viruses outweigh nuclear weapons. epidemic prevention needs such national defense. Right? Why I cannot? The viruses can be transmitted through different through different pathways, but most important is still through the close contact, and that through the airborne airborne pathways to our human mouth, and then get infected. So the mask is the very important tools to prevent the infection of such infectious diseases. Probably we don't. Anyway, now everybody knows the importance. Still, even this is the case, still in the world, a lot of people reject wearing masks. There are some statistics showing that no masks. Yeah, this is the infection rate. Without mask, the infection rate is very high. With masks, the infection rate is very low. These are the statistics along with different countries. Masks normally, probably even half year ago, we didn't know too much about the mask structures. We didn't care about it too much. Now probably more people get to know about it. Even this is the case, there's a still need to review what is the basic element of a respiratory mask. The materials normally use polypropylene because polypropylene is a very easy to process to make nonwovens. Currently, more than 6% of nonwovens are made of polypropylene. Secondly, polypropylene is very cheap, and maybe there are many reasons to use the polypropylene. It's water resistant. There's no water absorbency. So you can have water repellency. It's very bulky, so you can save materials. You can maybe able to become electric, etc. There are many cases, many reasons to use polypropylene. Polypropylene is really dominating material for face mask, and polyethylene sometimes, and PTFE, and many used for membranes. This is also very minority. So the key material used is polypropylene, and the fabrics can be made by melt blanc, can be made by span binding, can be made by span lacing. There are also some other technologies. However, these are the most representative technologies for nonwovens used for masks. And this we need to have the subjective evaluation. It should be avoid itching. It should be comfortable and fitting, and also it should be free of the odor. Just like we heard that from Professor Wang. Major characteristics we need to evaluate are bacterial filtration efficiency, particle filtration efficiency, virus filtration efficiency, blood resistance, flammability, drop pressure, etc. These are the key parameters for evaluating a mask. So we are used to the standard face masks. In fact, the face mask you mentioned is not so direct. It's a lot of work. It also has a lot of science. In general, we have this kind of 3-layer structure. The outside layer, we can make maybe the antibacterial, maybe to actually filter out. Here the filtering layer. The filtering layer can filter out these bacterial particles. But the outside layer can reflect the water, can also let the gas out. These are the normal structures, fabric structures for making the respiratory mosquitoes. If you look at their details, they are very different. Probably we know the mode blown. Mode blown is a very tiny fiber, 1 to 5 microns in diameter. This is normally span bindings, but this is also span binding. These two span binding are normally different. They cater for different purposes. In terms of mosquitoes, there are many types, but these are some kind of benchmarking. These are the benchmarking for people to source and to make and to develop different kind of face mosquitoes. The mosquitoes can be divided into two major categories: respirators and the surgical mosquitoes. These are typical the tools used for infectious disease control in hospitals for professionals. These are some of their basic the natures. For example, respirators normally have 4 layers of span-bound fabrics, and sometimes they use a little punch and 1 2 layers of mold blown. The mold blown, they normally use 2 layers of mold blown, and yeah, they have to get it charged so that they can capture the very small diameter particles. And the surgical mosquitoes normally have 2 layers of span binding and 1 layer mold blown for filtration. Also have the charge. That means they have high electrical pressure field. They put into high voltage electrical field to get a permanent static charges. Yeah, these are different types of respiratory or surgical mosquitoes. And then the structure of face mosquitoes. This is span binding. This mold blown. The span binding, you know how to, here are the binding parts. It's they probably 10 or 20 times of fibers thicker than the mold blown. The mold blown, these are the original the original picture, a microscope picture of the mold blown. This is we magnify it a little bit. This is how a mold blown fabrics look like. Why? Wait here. Okay. So why melt blown and how efficient is melt blown? Melt blown in Hong Kong, in China, because particularly in China, this is the first place where the pandemic starts, and China is very big. They had a huge demand for mosquitoes, and so there's some companies started to make mosquitoes and discovered that they don't have the materials. And these materials are called mold blown fabrics, non-woven fabrics. So they're looking for the technologies to the first to seek to understand what is mold blown and how to make the mold blown non-wovens, so that they can make respiratory mosquitoes for meeting the demand of the market. So mold blown now becomes for a while very hot at the time. So why is mold blown? Mold blown produces fibers from 1 to 5 microns, normally for face mosquitoes. Above that means the fiber thicker than this is not very good. They may not be able to achieve the properties we require. So mold blown, first of all, you can put PP resin into the feeder, and then there are hot air streams coming out from all around, and then they can draw the fibers into very small diameter of fibers, and they are laid onto a conveyor. This normally the fiber's diameter is from 1 to 5 microns, and at the later stage of the molded blown fabric winding up, the processing, they put high voltage electric field, and then the molded blown fabric get a charge, and later this can be called an electrode. This is a permanently charged material. So this kind of material can absorb a lot of small particles, so that it can provide very good filtration. So if we use the melt blown, we can have a submicron level fibers. They can ignore the melting temperature. Ignore the melting temperature, that's referring to the raw materials. The process is simple, productivity is high, solvent-free process. It has high surface volume ratio, so it has improved ideal filtration efficiency for respiratory muscles. So if we use if we compare the filtration efficiency, melt blown is much higher than spun bonding, is also much higher than the traditional textile fibers. If we just use the diameter, if we use the diameter of the fiber and then to discuss their efficiency in filtration, this is the the diameter dimensional scale. This is dimensional scale. This is a melt blown fiber. This is micro multiple fiber. This is nano fiber. This is the normal fiber. So you can see with the same volume of the normal fiber, we can pack many small fibers of melt blown. So many small fibers in between, you can see a lot of particles can get attracted. In this way, we can increase the filtration efficiency significantly. Yeah, we actually carry out some in order to in Hong Kong, we newspapers, media have been questioning different brands, have been helping the society to get a quality the masks. So I was interviewed. I was asked to make comments, to make them and to let them have the professional opinions. We tested the fabrics they provided, and also we bought some fabrics from the market. This is part of the data. This is a particle filtration efficiency. This is a pressure drop. Of course, we want to have the very high particle filtration efficiency, but at the same time, we want to keep the breathability. Breathability is related to the pressure drop. The higher the pressure drop, the more difficult for us to breathe. So actually, for this or some kind of masks, they can achieve very low pressure drop, a very high filtration efficiency. This is really good. However, so for some other cases, for example, this cover mask, they have not so high filtration efficiency, but they have extremely high pressure drop. So we found a lot of problems. This is one of typical problems for the existing masks in the market. Actually, filtration is happening just like in this figure. This is air. When they go through the masks, go through the fiber assembly, the pressure will the denser the fabric structure, the pressure drop will be bigger. So this is this is very important aspect to engineer for respiratory masks. And actually, in addition to non-woven, they're also knitted. They're also woven fabrics. It is found that actually non-woven is the best. This one is not very for the knitted and the woven fabrics. They cannot provide they cannot provide a good filtration efficiency at the same time to provide a very high pressure drop. So they are not very good at materials for face masks. Yeah, pressure drop. This is what we are doing. They have the pressure drop. The pressure cross mask is the measure of resistance to airflow. The pressure drop is inversely proportional to air fluidity. Pressure drop is additive and it increases with number of field layers. This is what I have. Filtration actually is very. If you look at scientifically, it seems to be a respiratory mask looks very simple. In fact, there are a lot of sciences here. The most important science is a filtration, particle filtration mechanism. This is normally a very good filter the filtration efficient profile should have. But if we divide this overall filtration efficiency broken into different components, you see they follow different profiles. So it's the final fabrics filtration efficiency is like this. So we can engineer this kind of profile by textile materials, by textile structures. And when the particle, this is the particle size. The particle size, this is 10 micron. This is the 0.1, maybe this is 0.3, something like that. So when the particle size is very small, for example, 0.1, the particles, the existing particles are normally very small, and they have they actually travel. They can be transmitted through diffusion, or they can be stopped by some way which can restrict the diffusion. In reality, the maskless static charge can actually manage this part very well, and this is essential. This is the the connection efficiency. The smaller the diameter, a face mask should connect more. This is due to the static charge. And there's also interception principle. This happened when the fiber diameter, when the particle size is within this range. Okay, they have very good. These are typical particle behavior. And this is the I think this is the impact. Yes, this is the impact. This is a setting. The setting, that means here there are different. They're describing the different mechanisms. So for the for the filtration efficiency control, we had to manage all these kind of particles in different range of diameters. So this is talking the diffusion part. Diffusion part has to be managed. This is normally managed by the charging, the permanent charge. Say it's happened here, and these are some of the examples we have. Say someone this filter one can have a very good filtration efficiency. This also has very good filtration efficiency, but their pressure this is their electric charge. Can you see the electric charge can affect the filtration efficiency? Here, when the electric charge is very small, so its filtration efficiency is very low. So particularly when the particle size is very small, because they cannot manage the particle size. And we also measure we collected a large number of masks, and we tested their fiber diameters. It turns out that a lot of masks have very large diameters. Of course, these are not very good mosquitoes. So this normally within this range, below five probably is acceptable, but the bigger the diameter, the performance, the poorer the performance of the face mosquitoes. So this is a sort of a distribution we have of the fiber diameters among the mosquito materials we have connected. Second one is the pore size. Pore size. Some of the mosquitoes has very high pore size. Of course, this is not usable. This is also very poor. This is poor too. This is a poor too. But this within this range, these are very normal. Probably this can perform reasonably well for the filtration efficiency. And good. This is from Japanese. This is from another one. Good mosquitoes. Their fabric pore size is quite small. They are not very big. So you can see the pore size of the face mosquitoes have a very wide range, and probably only half of them can meet the requirement. And the density that this is the square, the volume, the 1 square one cubic meter of fiber with this kind of weight. Probably within this range, they are okay. But the smaller the better, because weight can also affect the comfort, and also interfere performance of the mosquitoes. Okay, electric. Some of the fibers have extremely high electric. We do not know. We do not know whether electric can have elective impact or have some other functions. But some of them have very high electric level, because they want to secure. They want to have the very reliable filtration efficiency when the particles are small. Electric more or less they have some that, but they also have different quantities. For example, the smallest one is 0.1, but this one is 3. This is so many times of this. So it also varies. Probably this part is normal. Yeah, this is electric for different fibers. Now this is actually a true performance. This is most difficult, most important parameter for evaluating the face mosquitoes. PFE here is you can see none of them has reached the 90. Maybe this one is 95, something like that. But a lot of them dropped a little bit, and maybe this we can still think these are acceptable. But from here, I think from here very difficult to accept. So you can see in commercial world, there's still more than 50% of the mosquitoes are below the standard. Their filtration efficiency is much lower than the required, including maybe some famous mosquitoes. Yeah, PFE, this is another. And then we put different samples together. You can see this is more. We have more samples here. You see from here, maybe only 1/3 of them. 1/3 of them can meet the basic requirement of the a normal face mosquito required. Pressure drop. You can see there is also a very big challenge in reaching the pressure drop. The bigger the pressure drop, the filtration efficiency should be higher. But if the pressure drop is too big, we cannot breathe. This can adversely affecting our health, can even affecting our general function as a human being. So you can see this one extremely high. This also very, very high. Normal pressure probably is within this range. Okay, some not so many mosquitoes cannot match the standard. instead, a majority of them can meet the standard of the pressure drop. Yeah, air permeability is the reverse of the pressure drop. So they are quite they are similar. And you know, for different for when we do the data analysis, you can see different fabrics can have different filtration efficiency profile. This one are actually ideal or accepted, but this may not be, may not meet the standard of the of Moscow. So these are problematic. You can see the glass Moscows, even liquid fabrics, the Moscows can have some kind of filtration efficiency here. These are not very good ones. Strange. Why doesn't need? If we put things together, this is a air permeability. This is the diameter. So diameter, the bigger the air permeability, the better, the more breathable. However, if it's too big, it's too breathable, we cannot have the production. So this saying, some of them, the higher the diameter, they also the higher the diameter, higher breathability. However, they will bring very low filtration efficiency. Air permeability and this different types of fabrics. You can see when the some of the fabrics, some of the face masks have very high filtration efficiency. That means they don't have protection. But here probably okay for accepting as a face mask. We have been talking about the normally standard type of face mask on the market. They are supposed to be standard. They're supposed to have the required performance. However, we found out they are really not so ideal. There are a lot of problems existing. At the same time, apart from the standard face mask, there are also a lot of innovations in Hong Kong. In the past half year, we have suddenly established probably about 200 face mask the factories. Different companies have different innovations. They have different brands. They want to have different selling points. So different masks can create a lot of can create a lot of convenience to consumers. Can have a lot of functions. However, these functions may not be very reliable. You can see if we have a very close look at the interactions of face mask with our microenvironment near the mouse, there are a lot of problems. There are many factors we need to consider. You know, the masks. This is a mask. This is our lungs, our mouth. We have air. We have water. We have maybe even the toxic metabolic molecules coming out. So on the other side, there are also a lot of pollutants, in particular the virus carrier, and so there are a lot of things we need to consider. So far, respiratory masks are not very, have not considered the overall environment, overall performance, and the key comfort and healthcare aspects. So probably this is what we need to pay attention to in the future research. We have connected the data from the from our from our experiments, from our testing, and also literature. During the wearing process, a human being can have 50% of loss in evaporation, sweating, and can lose 90% of the of the air exchange, you can lose a lot of heat transmission. So there you can see that can cause a lot of problems. So we need to have some further innovation and scientific research. And our student looked for some examples in the market, but this is very may not be very representative. However, it's maybe important. Wool materials for masks. Maybe this is interesting to Professor Xun Kai Wang. Wool has been considered as energy-free material for face masks, and also there are some reports that the wool fabrics can make the virus die much more quickly. So wool may be a very good material to study. And there are also some other innovations, including carbon filters. Carbon filters may not be able to carbon, graphene, etc. They may not be able to stop the viruses. However, they may be able to control some smell, something. So it's also very good candidate material. And transparent. Another very important demand from market is the transparent mask. You can see, for example, for deaf people, they can they want to convey their message by their lips motion. So there are transparent masks. I don't know their performance. They claim they're really good enough. But anyway, there are a lot of innovations in the market for face masks to combat the COVID-19, and this are probably very good tool for infectious disease control. Not only for COVID-19, it's also for other kind of infectious diseases. My brother and my sister-in-law are both doctors. My brother is a department head in controlling the in the infectious diseases section. So he said, since people wearing since the COVID-19 happening in China, the biggest problem for the hospitals that they don't have the patients, particularly the children's departments. The children's don't have flus, don't have a lot of respiratory problems. They are free of respiratory problems. Particularly during the spring session, during the spring and summer transition period, normally there are a lot of diseases. So the respiratory masks is a very, very important tool for general infectious diseases control, in addition to COVID-19 virus. So the COVID-19 is a pandemic much more powerful than the war. Face masks have become the most important protective tool. Majority of the masks in the market do not meet the standards. We have to be very careful. The account for the healthcare become very urgent. Innovations are required for more and better economic designs. New technologies are required. Okay, that's it from me. Thank you very much for your attention.
Thank you, Professor Hu. It was a very nice, interesting lecture with a lot of information on the masks. And a lot of questions also are there from the audience. Before going into the questions, it's really I'm very happy to see you after a long time. I hope
yeah, Professor. Yeah, I also not see you in the same place in the.
Yeah, I'm still in IIT only.
Yeah.
I hope your journey from PolyU to CityU has been very fruitful.
Yeah, it's very good. The CityU is much more open. There are better resources here.
Okay. I'm happy to inform you that our common student, Dr. Bipin,
he's with you. Is that right?
Yeah, he's with our department. He's doing well.
Yes, he was your student. Last time when he was here, and you actually we met in PhD. That's 2015 something, 5 years ago probably.
Yeah. You will be happy to know that he is also in the field of masks. He has.
Yeah. He sent to me the video, the media report of his work. Yeah.
He has a startup and they are manufacturing and selling also
I see.
in the brand name Kavach.
Oh.
One interesting thing is that he is using knitted fabric as the inner layer and nano-woven, I think, melt-blown layers in the middle and woven on the outside. And the claim is that the comfort, you talk a lot about the nano-woven masks. How do you feel about this? That having comfortable.
If we needed the fabrics masks, I think little fabrics masks made of little fabrics. You mean?
No. Knitted fabric as the inner layer.
Inner layer. You mean melt blown fabric?
Melt blown in the middle and some woven material on the outside.
Skin contact layer. Skin contact layer.
Yeah. Skin contact layer.
Oh, skin contact layer. Inner layer. Yeah.
Inner layer, soft knitted material. So how do you think about that? Is it, will it be able to outperform 100% nano-woven?
Actually, that's a very good question. Originally, people may feel a face mask has 3 layers. There are 2 span bonded, and there are 1 melt blown. Actually, the inner and the outer layer, even for the standard masks, the outer and the inner layer are actually different. Let me show you. Yeah, the inner layer structure is normally much more smooth. There are no bonding. There are no direct bonding spots. At first it's very different, but still made of. They're relatives, but the structures are much better, much more skin friendly.
Yeah. I tried Kavach also. So knitted fabric as the inner layer, soft material.
Yeah, much softer. But still, can you see this picture? You can see this one. This is the outer layer. This is the inner layer. Inner layer is somewhere in between these two. In between these two. It's just in between. This one, can you see? Almost every mask outer layers has this kind of spots. These spots are actually pointed. This is upon the bonding. These bonding parts. These are melting part. This part is is solid. Probably here there's no breathability. This can become very harsh. So this kind of fabric cannot be used for the inner layer. The inner layer instead, and structurally very similar to the melted blown, but the fiber diameter is much thicker.
Okay.
However, there's also new technologies. They use core shell structure. They use core shell structure. They use the the bicomponent core shell or side by side structure, and then they can make them together, and then they can have much more skin friendly structures. This this fabric, these are the requirement for the skin layer is much more delicate. We have on the other hand, I think woven fabrics and the leaded fabric are not suitable for masks because they have the staple fibers. These fibers are very can cause itching, can cause allergy, can also maybe cause some respiratory allergy. So these are the considerations for the inner layer.
Okay. Now I come to some questions from the participants. I try to select some of the important questions here. One, Professor Rangam Rajkova, his question is, how long the charge in melt-blown fibers are maintained? Probably he refers to the electrodes that you talked about. What factors?
How far the electrode can maintain, is that right?
Yeah. So what factors increase the charge?
Okay, theoretically, yes, dear. Theoretical electric can be there permanently. This is why it's called electric. By definition, electric is a permanent charge material. Okay. However, it is said only 3M and company clock they have their own patented technologies. They can really reach the permanency of these masks. And on the other hand, from industries, I have been doing consulting with a number of companies. Their electric charge cannot maintain for too long, and then maybe 1 week, maybe 2 weeks, they defect, they actually decay very easily. So a lot of people are doing electric charge during the processing stage very severely. They may have 2 electrodes, they have 3 electrodes, 4 electrodes. They try to use more electrical fields to get a more permanent electric charge. However, this multi-blowing process is very energy consuming. This can sometimes they cannot really have sufficient electricity to do that. So this is depends. I think electric materials, the electric permanency depend on many factors. First, the raw material. Secondly, the treatment process. Thirdly, the general environment. I think the melt-blown raw materials, normally polypropylene, have to have some additives. You have to have some materials to hold the permanent charges. Okay, have I answered the question?
Sir? Sir, Algrisami sir?
மியூட் பண்ணிருக்காருங்க மேம்.
இல்ல அவங்க முடிச்சிட்டாங்கல்ல.
Thank you.
Hello?
Thank you. Thank you.
Yeah. Okay.
Okay, sir. Okay, sir. Now you can continue, sir.
Yeah, Professor Hu, similar connected question is what will be the effect of washing on the electric?
Electric washing. As I said, if the material, the raw material is right, if the electric treatment is permanent, washing may not degrade it so much, because there are some testing results from US. You know, the electric can maintain or the filtration efficiency can maintain even for the steaming for some other time. But what we have tested, there are more or less some kind of degradation. Depends on the decay of the electric charge. Depends on the brand. Depends on the fabrics.
Okay, I think that's good. There is another interesting question from Umapati, a participant. The size of the virus is very small in the scale of nano, but the pore size in the nano ones are nearly 10 times or 100 times larger than that.
Yes.
His question is how exactly this filtration or how the virus are captured.
Actually, this is exactly what the electric should do. We have some other data that are not presented here. The electric, the electric, the particles. Can you see smaller than 0.3, 0.1? These are normally managed by the electric charge. So actually the bigger the pore size can allow more static charge stay. So this can actually very effectively manage the small particles. So in the standard testing of face mask, they normally tested either 0.1, 0.3 nanoparticles. That's 100 or 200 nanoparticle size. This reaches very the maximum level 95% and 99%, etc. So indeed, by static charge, I haven't the data here, but we do have the data somewhere we tested. When you have good static charge in the material, in the filtration layer, the pore size does not matter too much, because the static charge is so effective to attract the small particles.
Yes. So particle size are maybe very small, but if the pore size is larger, you can have multiple layers. So you will have a tortuous path which will trap the finer particles.
I think it doesn't need to have too many layers. It's within, actually, for multiple fabric, if you add some if you add an electric charge, the pore size is increased, because the electric charges can repel each other, can dispel each other. So the pore size is increased. While the pore size is increased, they can accommodate more static charges. More static charges can actually attract more small particles.
All right. Another question from Professor Giridev from Anna University is how the relative humidity and other temperature conditions influence the selection of a particular type of mask.
You mean I know what you mean. For example, Hong Kong has a very high humidity level, and maybe India also is very humid. Is that right?
Yeah,
so
in some places.
I think
yes.
you should choose different masks. You have to choose better quality permanent ones. If the fabrics are not very well treated, and the static charge is not very stable, this can cause a lot of problems. The one of the problems is that the charges can go very quickly. Static charge is very sensitive to humidity, so for sure this is a very important parameter. So you have to really make sure that the multiple is well treated for static charge.
Okay. Another question from Mr. Vaidiswaran. What type of masks are preferable for children? Should it be separate consideration for them? And do you recommend any special type of masks for children?
Yeah, that's also a very good question. First of all, the children are too small. They are not. They better not to wear too much, too often, too long hour of masks. There's some kind of reports I noticed before. At the same time, I think they should have the inner layer should be much more careful. We probably need to use the some the ES fiber. A fiber that by component fiber that can provide a much more softness, better softness and touchness.
Okay. Okay. So that makes sense. I think there are other questions also. Let me stop here with looking at the time. I think we are the session here.
Okay.
I don't know whether the second speaker has come or not, Mr. Bose.
Sir, BKC Bose are not available, sir, due to
Okay.
network problem. We will bind this session, sir.
Okay.
I
So,
can quit. Is that right? I can stop the sharing.
okay. Thank you, Professor Hu. It was a very nice, interesting discussion and very nice presentation. Thank you very much.
Thank you.
I think the organizers can take over from here. The other questions, I think those who are left out, you may send an email to Professor and ask the questions.
Yes, that is fine, sir. Dr. Saktivel.
Madam, I will just wind up. I would like to thank Professor Alagurisam sir for sharing this session. Thank you, sir. And
you are welcome.
To thank speaker Professor Dr. Jungaiwan and Professor Dr. Jillian too. Thank you, madam. I also thank all the participants for their active participation. I request all the participants to join back by 1:30 p.m. using new link for the next session. Madam, is it okay? 1:30 p.m.
Yeah. We'll start at 1:30, I think. Still we have time, no? Half an hour time is there. More than half an hour. Okay, no, sir.
Okay. Dear, you have a new link. Dear participant, you have a new link. You can just connect by next session by 1:30 p.m. Thank you all.
Yeah, the link is session wise. Participants can check the new link given in the group mail, everywhere it is given. Session wise link is different. And due to heavy rain, PKC Bose had some issues with his network. He could not join. Maybe we will try to get his paper and maybe share it with the participants. With this, we thank all of you. We will resume from 1:30. Personally, I would like to thank Professor Zindian and Professor Zungaimal. Thank you for sparing your valuable time and always associating with us. Thank you very much.
Thank you. See you.
Thank you, Professor.
Thank you. Yeah.
Okay, so enjoy your lunch.
Yeah. Yeah.
The lunch already before my presentation because we have 2.5 hour difference.
Yeah. Thank
Okay.
you. Thank you. Participants can resume joining at 1:30. We will start sharply at 1:30. By the paper will be by, I think, second session, plenary session. I think we are starting with Professor Prasad Potluri, sir.
Okay, ma'am.
Are you there, sir? Prasad, sir? Ganesan, is he there? Ganesh?
Ma'am?
Prasad Potluri, sir, is there in the connection?
Ma'am, I will check.
Morning, I saw him. He was there.
Yeah. Ma'am, he is there, ma'am.
Okay, sir. Prasad, sir, are you listening? Sir, can I talk to you?
மியூட் பண்ணிருக்காரு.
Okay, but அவரு தான் அடுத்த first session இல்லைங்களா? Second session, first paper is this paper. Professor Michael Rausch, are you there, sir? Michael Rausch. சக்தியில் நான் பேசுறது கேக்குதுல்ல? Professor
audible, ma'am.
Clear, audible.
Professor Prasad, sir, are you there? We will join at 1:30 Indian time.
Yes, I can join it, yeah.
Ma'am, he's available now? Pardon me?
He's available.
Yeah, he's talking. Can you hear me? Yeah. But I'm not able to see your video. Okay. Yeah. Okay.
Sorry, I switched it off during the talk.
No problem.
Now clearly.
Hello.
Yeah,
I'm
fine.
able to join at 1:30, yes? It's no
Yes,
problem.
Indian time 1:30.
Yeah,
Yes,
sure.
I will join, yeah?
Yeah, thank you.
Another 35 minutes.
Yes, sir. For you, paper is the first paper, sir. Prasad, sir, paper. Second is Professor Rausch. And maybe the third paper is Rangam. Professor Rangam is also there in the line, I think. Professor Rangam?
I think he is there. He sent a question also.
Yeah, he was there, sir. Okay, sir, we will join at 1:30. I also thank Professor Alagurusamy, sir, for his continuous support in all our activities. Thank you, sir.
Thank you. Thank you. Nice seeing you.
I thank all participants for their patient listening. We will resume at 1:30 Indian time. 1:30.
Thank you very much.
Yeah.
Okay. Bye.
Bye.
Thank you, sir. Okay.
Dinesh, sir.
Sir, I'm there. Line la irken.
Sir, மறுபடியும் நாம வந்துட்டு இத இது பண்ணலாம் சார்.
ஒன்றும் ப்ராப்ளம் இல்லை சார். நம்ம 1:15 அப்ப நம்ம ஸ்டார்ட் பண்ணிக்கலாம். நான் உங்களுக்கு கண்ட்ரோல் கொடுத்துட்றேன். சஜீஷ் வந்துட்டு வில் டேக் கேர் சார். தேர் இஸ் நோ இஷ்யூ.
ஓகேங்க சார். பட் வந்துட்டு இப்போ நம்ம இது வந்து வெளிய வந்துட்டு லீவ் மீட்டிங் கொடுத்து வெளிய வந்துட்டுமா?
லீவ் மீட்டிங் கொடுத்துட்டு வந்துருங்க சார். ஒன்றும் ப்ராப்ளம். என் மீட்டிங்கே கொடுத்துடலாம். ஒன்றும் ப்ராப்ளம் இல்லை. எனிதிங் எல்ஸ் சார், நீங்க லாஸ்ட் டைம் பண்ண சின்ன மிஸ்டேக்லாம் இருந்தது. அது சஜீஷ் வந்தாருன்னா நான் செக் பண்ணிடுறேன். நான் கரெக்டா 1:15 நம்ம ஸ்டார்ட் பண்ணிட்டோம்னா கரெக்டா இருக்கும். ஓகேங்களா? அந்த மீட்டிங் சில விஷயம் மீட்டிங்
தினேஷ் அவர் இருக்கிறார் பாருங்க. சஜீஷ்
இருக்கேன் சொல்லுங்க.
ஓகே, ஒன்றும் ப்ராப்ளம் இல்லை. என்னன்னா அந்த மீட்டிங்ல வந்து பார்ட்டிசிபென்ட்ஸ் நீங்க கிளிக் பண்ணீங்கன்னா மியூட் ஆன் என்ட்ரி வந்து கிளிக்ல இருக்கட்டுங்க. ஓகேங்களா?
ஓகே.
சார் வீடியோ எதுவும் மியூட் பண்ண முடியாதாங்க சார் அவங்களோட வீடியோவை? ஒரு சிலர் வந்து உட்கார்ந்து சாப்பிடுறாங்க.
இல்ல நம்ம வீடியோ மீட் பண்ணனும்னா நம்ம பார்ட்டிசிபென்ட்ஸ் நம்ம இவங்க வராங்க பேனலிஸ்ட் வராங்கல அவங்களோட வீடியோவும் மீட் ஆயிடும்.
சார் ஒண்ணு இல்ல சார், பிரகாஷ் பேசுறேன். என்ன சார்?
சொல்லுங்க சார்.
சார் மத்தவங்க யாரும் ஹோஸ்ட் எடுக்க வேணாம்னு சொல்லிருங்க சார். மார்னிங் வந்து நம்ம திரும்ப கிட்டத்தட்ட ஒரு 4 லிங்க் கிரியேட் பண்ற மாதிரி ஆயிடுச்சு.
இல்ல எனக்கு பிரகாஷ் சார் என்ன ப்ராப்ளம் ஆச்சுன்னா மார்னிங் வந்துட்டு நான் கணேஷ் சார்ட்ட கண்ட்ரோல் கொடுத்துருந்தேன். பட் ஆனா யூடியூப் லைவ்ல வந்துட்டு நிறைய வந்துட்டு நீங்க இப்ப நம்ம பேசுறப்ப கூட பிரச்சனை வந்ததுன்னா சமாளிச்சிடலாம். யூடியூப் லைவ்ல போறப்ப வந்துட்டு உங்களுக்கு லிங்க் வந்து நீங்க மாத்தி நம்ம வந்துட்டு இந்த மாதிரி வந்து பீப் சவுண்ட் அது இது வந்துட்டே இருந்தது. நான் எல்லாத்தையும் அப்புறம் திருப்பி நான் கண்ட்ரோல் எடுத்து எல்லாத்தையும் ஆஃப் பண்ணிட்டேன். ஆஃப் பண்றதுக்கு அப்புறம் தான் பீப் சவுண்ட் என்ட்ரி அண்ட் எக்ஸிட் பீப் சவுண்ட்லாம் கட் பண்ணிட்டேன்.
ரைட், ஒன்றும் பிரச்சனை இல்லை சார். இப்போ நமக்கு ஹோஸ்ட் வந்து ஒருத்தர் இருந்தா பிரச்சனை இல்லை. ஏன்னா திரும்ப நம்ம வெப்சைட்லயே நம்ம அப்டேட்
இல்ல சஜீஷ், அதனாலதான் நான் சஜீஷ் பேசியிருக்கேன். சஜீஷ் அவர் வந்துட்டு சொல்லிட்டாரு நான் தெளிவா பாத்துக்கிறேன்னு சொல்லிட்டாப்ல. ஒன்னும் ப்ராப்ளம் இல்ல.
ஓகே சார். ஓகே,
நான் உங்களுக்காக ஆக்சுவலி வந்துட்டு எனக்கு வந்துட்டு 10 o'clock வரைக்கும் வீட்ல இருந்து ஸ்டெப் பண்ணணும் சொன்னாங்க. திருப்பி ஆபீஸ் ஸ்டெப் பண்ணணும்னு சொல்லியிருந்தாங்க. பட் நான் இப்போ ஆஃப் டேவே ஃபுல்லா ஆயிடுச்சு. இங்க வீட்ல இருக்கேன். நான் இன்னும் கிளம்பல ஆபீஸ்க்கு. இந்த முடிச்சு
நான் கணேஷ் சார்ட்ட சொல்றேன். கணேஷ் சார்
சொல்லுங்க
சார். வேற